Now we're going to look at difference of squares and how that is going to pertain again to this type of question, this type of section, excuse me. So difference of squares and what that looks like. So what I like to do, difference of squares kind of has its own name, but it really is just a trinomial. So I want you to learn how to look at something written the way that it is here, x squared minus 4. I want you to think of it as x squared plus 0x minus 4. Because technically, if it starts with x squared, it's a polynomial, which means it should have 3 terms. So I want you to consider that that's a 0. And then if you can think about it like that, then when we work these just like a trinomial, we just realize we have to get a 0 in the middle. The only way you can get a 0 in the middle is if the two numbers on the outside and the inside are the same. So 2x and 2x. In order to get a 0, one would have to be positive, one would have to be negative. And that's it. So all you have to do is really think about having the same numbers. And then that way you're not learning another method. It's a method that you already know. You want to have the same numbers and then one positive, one negative. So in this case, I'm going to think about it as, okay, break up the x squared would be x and x. Then I want to break up the 25. I have to use 5 and 5. 1 and 25 are not an option. And I want to get a negative in the middle, which means I need a positive and a negative. Bam, no problem, because this would give me a negative 5x and this would give me a positive 5x, which is 0. Okay, so same thing here. You want to consider that you have a 0x in the middle. So I would have to break up 4x squared as 2x and 2x. And then I want to break up 9 as 3 and 3. And I want to make one positive and one negative. Again, because I want that 0 in the middle. All right, so what does this look like for our section? And a question like number 2 on page 94, you have a GCF, so we're going to still take that out. That hasn't changed. So we're taking out m. We're left with m to the 4th minus 81. So we're going to look at this inside part and say, okay, well, that almost looks like it could be a difference of squares. Let's try it. So we'd have m squared, and m squared would be the breakup of m to the 4th. 81, I would use 9 and 9. And then I would make one positive, one negative. That seems perfect. Just don't forget to bring down your GCF that you started with. Now, if I was not paying attention, I might be finished with that and go ahead and turn in my paper. However, I'm not completely factored because this guy over here is also a difference of squares. So this will be, leave all the things that you have so far. So these two just kind of drop down. But m squared minus 9 can still be factored again as a GCF. So that would be m and m, 3 and 3, one's positive, one's negative. This is the complete factorization. Now I know I'm going to have somebody that says, why in the world could you do that for the m squared minus 9, but not for the m squared plus 9? Okay, so let's consider why. If I use 3 and 3, there's no way for me to take 3m and 3m and get 0 without one being negative and one being positive. Well, if I had one negative and one positive, positive 3 and negative 3 give me negative 9, not positive 9. So that's why this is actually called a difference of squares, is because it has to have the difference or the subtraction sign in order for the rule to work. Okay, let's look at number 7 next. So I'm looking at a GCF of 10. If I take that out, I'm left with 81k to the 4th minus 16. I'm going to leave the 10 and look at this as 9k squared. 9k squared, 4 and 4. One positive, one negative. So I want you to look at that and see if you think we're done. Hopefully you were thinking that we are not done. The reason we're not done is because of the 9k squared minus 4. So again, I'm going to leave my GCF. I'm going to leave this 9k squared plus 4 because that is not a difference of squares. And then when I get here, I'm going to say, okay, well then that's just 3k minus 2 and 3k plus 2. All right, and then number 12, I'm going to take out a GCF of 3m squared. So I'm left with 1 minus 16m to the 4th, it looks like. This, hopefully you're thinking already, is a difference of squares. I'm going to leave the 3m squared, and I'm going to make this 1 and then 4m squared. 1 positive, 1 negative. Now again, you want to double check. This is another difference of squares. I'm going to move down here to write this. So my GCF will be 3m squared. My 1 minus 4m squared is going to be 1 minus 2m, 1 plus 2m, and then times 1 plus 4m squared. And that's it. So good luck. Practice, practice, practice.